Hello, my name is Samuel Judge. Today I'm going to talk to you about how to hide in the age of machine learning. So we are at a strange crossroads where what is considered identifying is constantly changing on our feet. For example, we would all agree that things such as our name and our social security number and even our home address are considered personally identifying. That is, information that can tie you as an individual back to something. The problem is that this is changing constantly with machine learning. What machine learning uses to determine who you are is not what it used to be. For example, your biometric information, your computer IP, even your university information can be tracked back to you now. And the list just continues to grow. And so we are at a position where we are going to have to retroactively go back to information that has already been published to correct this issue because it's going to contain personal information. So I propose to do this by building an encryption machine. The idea is that the average user of data who has a large data set that needs to be depersonalized can tell me what columns need to be depersonalized. It will run through my machine and I will return back to them a de-identifying piece of data, their data set, that they can publish. So I want to make a quick note here about the encryption I'm going to use. I chose the Rindale cipher for two reasons. The first and most important is that it provides a one-to-one mapping. So that is to say that Samuel Judge gets mapped to a different place than Aaron Rodgers. And this is important for research because it's essential that people be able to identify person A as person A. It's just not essential that they know that person A is Samuel Judge. The other thing is that it's a symmetric key algorithm, and in some regard, I just decided that it would be easier to keep an eye on one key rather than to try to build a asymmetric key algorithm. So here we're going to see what happens with my data. We start with something that is comma or line or tab or new line delineated, and then we enter in our information, such as where is the S3 bucket, what is my write path, am I encrypting or decrypting, what is the delimiter, and then also what columns do I want encrypted. It runs, and then I take a look at the data. If you look here in the S3 bucket, you'll see that it has now encrypted the data set that we wanted. And this is the name, and then over here, you'll see the zip code. So let's talk about the process I use to get this done. All right, we have the front end, of course, and then I'm going to assume that my user doesn't have sophistication to handle large data sets. So they just drag and drop into an S3 data storage. And then my Spark pulls their S3 data based on the file path that they give me, and then processes, distributes the decrypting or encrypting, and then writes it back to the S3. This is where the problem occurs with my pipeline because we wind up with memory errors. First of all, the data could be too large for the nodes, and this is easily handled by splitting the data up. But the problem is when I try to write back to S3. S3 has the disadvantage of not being capable of allowing you to append to the end of a document. And so you have to write it all at once. But to do this, you need to pull it into a single node, and this would often overload my master node. So I came up with two solutions. The first one is I first wrote to a MySQL database, and then from the MySQL database, put it into the user's S3 storage. This had a problem in the sense that it took a lot of time. It was very time consuming and really made it unfeasible to use. On the other hand, I bought a larger master node. And when I bought a larger master node, it was able to handle the memory issues. I want to take a quick note here. You'll see here at the key storage, that is my own personal S3, so I hold on to the key and not the user. The nice thing about it is that it's scaled linearly exactly as we'd expect. It at least tells me that there were no obvious errors. On the x-axis here, we have log of the number of lines, and on the y-axis, we have log of time. And they're linearly related, which is fantastic to see. So again, my name is Samuel Judge. Before I came to Insight, I was an assistant professor at Northeastern University. I have a large family. This is them up to the top left. I'm a Michigander originally. And then in my free time, one of the things I like to do is create math art, and I do it using Mathematica, and here are some examples of it on the left, bottom left. Thank you for your time.